Good evening all of you, and here is a problem based on probability and vectors. And in a recent JEE advanced problems, it has been seen like they very nicely combine problems from different fields. So let's start with this problem. We have three set given STU. So what is set S? It's a set which contains the vector x u vector plus y v vector such that xy belongs to -1 to 1. U and v vectors are unit, and u and v are not collinear, means they are not in the same proportion. Now this restriction of u and v, unit vectors, and they are not in same proportion, is present in all the sets. So just for the sake of simplicity, I am not writing. Now the first question is, what is the conditional probability of t given S has occurred? So before we go further, let's visualize the situation. And let's try to draw the set S. So a set of all vectors such that x, y belonging to -1 to 1. So let's say if you have u vectors like this and v vector over here. So given u and v. Now if I multiply u with -1 to 1, so maximum I can go to u, minimum I'll go to minus u. So negative u direction. Similarly, maximum I'll go to b and minus b. So if I'll see all the combination of u plus b, next team by law of parallelogram, we can get any points within this parallelogram. That you can feel very easily. Let's say if for a particular u, you keep on changing b. So let's say u is there, and if I take this b, I get exactly this point. For other proportion of b, I'll get this point. So for maximum b, I'll get this point. So for v fixed, I'm getting this one. Let's say if u is u by 2, then again I'll keep on getting all these points as shown in the diagram. So it will give the entire region bounded by u and b as a parallelogram. Similarly, on the other side by symmetricity, I'll get the same answer. Okay, so as you can see, we are getting these two parallelogram chunks. So this is nothing but set S. Now let's come to the set T. Now set T is 0 to 1. Okay, so it's set T contains, instead of x and y, let me use this symbol now, C and D. Sometimes they'll keep on changing the symbol, okay, so that to get a feel of the question, because I'm not all obliged to use the same x and y symbol. So here maybe instead of CD in the third U, I could have used T and S. That would have been a better way of asking question. So let's say this is T and S. T belongs to here, S belongs to. So now clearly set T is C is from 0 to 1. It means U is 0 to 1. So still you have this one. But this time D is from -1 to 0. Okay, so similarly we'll get minus b and b, so this combination. But this will also include other combination as well. For example, this chunk of the parallelogram is also included there. Similarly, this chunk of the parallelogram. Okay. So this is our set S. Set S contains this entire figure, which is a bigger parallelogram. Now let's come to set T. And set T definition, as you can see, Cu plus dv. C belongs to 0 to 1, D belongs to -1 to 0. Similarly, set B. So set T is C 0 to 1. So U will go from 0 to 1. So we are in this region. And D is from -1 to 0. So we have only one part out of this. Okay. So only this chunk, this Kaju wala barfi. Let me draw with this diagram. This chunk will come into picture. So if I'll draw it again, just for the sake of simplicity, so we'll have only this chunk into picture. Okay, so according to this rule, what is probability of T intersection S divided by probability of S? So clearly देख सकते हो T intersection X is just one part out of 4. Okay, so if this quantity, if this sample space, if I'll see this area as let's say 4, if I take this as unit area 1 1 1 1, so probability of T intersection S will have one element out of 4. So its probability is 25%. Similarly, you can see how to do second part. P of U intersection S divided by probability of S. P of S is already 4. If I make it proportional to area. Now how many elements are in U and S? Clearly, U is from T equals 0 to 1. So still the same story for U. T equals 0 to 1. So we will dance from here to here. But this time S is more than 1. Okay. S is more than 1. So if you have U over here and V over here, that means more than B now we have to take. Okay, more than B. So that will give me answers in this region above this. So which is not the part of even our initial sample space. So for the second place, answer will be 0, probability will be 0. Third case again you can calculate very easily, because this amounts to probability of T intersection U divided by probability of U. So suppose these 6 are the given sets, which is defined as follows. Okay, now the question is let's define a set S which is union of Si I equals 1 to 6. Right. Now suppose 2 points are selected, or 2 vectors are selected from this set. So let's say we have T belonging to S. This is a set of all vectors which belongs to this. So we have to find for any 2 vector T1 minus T2 the minimum and maximum distance, where mod of T1 minus T2 represents distance between tip of 2 vectors T1 and T2. Second question is more challenging, which I'll solve in the next lecture. Suppose there are 3 surfaces given by their set. So it has mentioned those sets represent surface. Let's say Sj, Sk and Sl. So suppose Sj represents some surface. Similarly, we'll have Sk and Sl. Since it may be in 3D, so I'm just giving you a planar view by folding it. Now the question is, the circle Cj, Ck and Cl are drawn on this surface respectively. So how many circles we can draw? Infinitely many. Okay, touching all the sides of these surfaces. So now you'll have unique circles. Okay, because all these sides will be some surfaces, maybe square rectangle, that you can check. I don't want to reveal that. And let's say if Pj be the point on Cj, Pk will be the point on circle Ck, and Pl be the point on circle Cl. So we'll have 3 point movable point here. Okay, you have to find the minimum perimeter of the triangle formed by them. So if I'll make a triangle by Pj, Pk, Pl, you have to find the sum of distance to be minimum. Okay, and also find the minimum distance. So second part is a bit challenging, which I'll be solving in next lecture. First part is the minimum distance is not that difficult, because as you can see, this surface represents nothing but, from our previous discussion, the surface of the cube, unit cube actually, because Ci plus dj will be, if we have I vector and j vector, C is from 0 to 1 and d is from 0 to 1, so that will give me base of that cube. So on this base, the cube is raised. Similarly, you'll have second surface, as you can see, j plus k, and third is c plus d. So in the next part of the problem, in fact, you can clearly see if I'll just select x1, s2 and s3, there will be 3 adjacent surface of this cube, right? So if circles are drawn on these 3 adjacent surface, you have to find the minimum perimeter of the triangle such that the points circulates on the corresponding